This is section 8.6 of Accelerated Geometry, and it's called Area and Similarity. So there is a PowerPoint that goes with it, and I am going to kind of walk you through the investigations. So I'm going to draw two rectangles. So here's one, and I'll draw the other one bigger than that. And I will say that these are similar. So I'll make this be 6 and the corresponding side be 9. This is 10 and the corresponding side is 15. So now if I look at the sides of these two rectangles that I say are similar to each other, I will take the side of 6 and put it over its corresponding side of 9. And then if I divide the top and bottom by a 3, I'll get 2/3 as the ratio between those two sides. If I set these up correctly, that these really are similar, then I should get the same thing when I do the other sides. So if I take 10 and put it over its corresponding side of 15 and divide the top and bottom by a 5, I will also get 2/3. So that means that the two rectangles, since they have all their angles equal and their corresponding sides are in the same ratios, these two rectangles are definitely similar. Now, just for fun, I'm going to look at the areas. So if I look at the area of this, it is going to be 6 times 10, and 6 times 10 is going to be 60 square units. If I look at the area of this similar rectangle, I'm going to go 9 times 15, and 9 times 15 is 135. So now I'm going to take the areas, and I'm going to make them be a ratio also. So I'll take 60 and put it over 135. Now I know 60 and 135 can be divided by 5. I'll start there. So I get a 12 on the top and a 27 on the bottom, but then I can divide again the top and bottom by a 3. So I get a 4 on the top and a 9 on the bottom. Now, what I'm looking for is a relationship between this ratio of the sides and the ratio of the areas. And right now, they are not equal to each other. However, let's see something cool here. 4 can be rewritten as 2 squared, and 9 can be rewritten as 3 squared. Look what I have. I'm going to erase this yellow, and I'm going to come over here and say, now look at this. If the sides were in the ratio 2 to 3, the areas were in the ratio of 2 squared over 3 squared. Now I could do this with a bunch more examples, but they're all going to turn out to be the same. So now if I go to the PowerPoint, and I come over here, right over here is the conjecture number 73 for what we just discovered. If corresponding side lengths of two similar polygons or the radii of two circles compare in the ratio of m over n, then their areas compare in the ratio of m squared over n squared. So that is conjecture number 73 that should be added to your conjecture list. Now there are a couple of examples here. Problem number 1 says that these two triangles are similar to each other, and they tell you that the area of the left one over the area of the right one is 4 over 1, and they want you to find out what xz is. So what I do first is I look at the areas, because that's what they're talking to me about. They say the areas are in the ratio of 4 over 1. Now what are areas? M squared over n squared. The lines are m over n. So to get from m squared to m, I have to take the square root. The square root of n squared is n. The square root of 4 is the square root of 4, which is 2, and the square root of 1 is the square root of 1, which is 1. So therefore, the lines are in the ratio of 2 over 1. So sides, anything in straight in that figure are going to be in the ratio of 2 to 1. So therefore, if I take BD over XZ, the corresponding sides, they would be equal to 2 over 1. Cross multiply, and no, I didn't. I said BD is 22, right? So I substituted in a 22 for BD, and now I can cross multiply. 2 times XZ is equal to 22 times 1, and then divide both sides by 2, and I have XZ is equal to 11. Okay, problem number 2. The ratio of the areas of two similar trapezoids is 1 to 9. What is the ratio of the lengths of their altitudes? Okay, so they're telling me about the areas being 1 to 9. Areas are m squared over n squared. To get from m squared to m, I have to take the square root. Take the square root of n squared, I get n. Take the square root of 1, I get 1. Take the square root of 9, I get 3. So that would mean the ratio of their altitudes, the straight lines in the figure, are going to be 1 over 3. And then here's the last problem. If you need 3 ounces of shredded cheese to cover a medium 12-inch diameter pizza, okay, 12-inch diameter pizza, that's a straight line. If you need to cover it with 3 ounces of shredded cheese, that's an area, covering an area with 3 ounces of shredded cheese. How much shredded cheese would you need to cover a 16-inch diameter pizza? So these are straight lines, and I'm wanting to know about the area that of shredded cheese to cover that pizza. So this is what it says. The ratio of the pizza diameters is 16 over 12. If I divide by 4, that's 4 over 3. Therefore, the ratio of the pizza areas is 4 squared over 3 squared, or 16 over 9. Let x represent the amount of cheese needed to cover the large pizza, and then set up a proportion. So the area of the large pizza over the area of the small pizza is the same thing as the amount of cheese for that large pizza over the amount of cheese for the small pizza. So the large pizza, the area of the large pizza is 16 to 9. So that's what we said back here. So therefore, the large pizza, we don't know how much cheese. The small takes 3 ounces. And then if you cross multiply and solve for x, it would give you an answer of 5 1/3 ounces of shredded cheese.